We have a Pratt truss here that we're going to determine the forces in members DE, EJ, and JK, and we're also going to determine whether they're in tension or compression. We have an external force at C of 100 newtons, at D of 250 newtons, and at H 125 newtons. So the first step we're going to do is we're going to solve for the reactionary forces. By simple observation, we can state that AX is equal to 0 because there are no forces in the x direction. We're going to then use the summation of forces, or the moments about A, and solve directly for G, and we get 181.3 newtons upwards. Then we're going to do the summation of the forces in Y, and we can then solve for a Y, which we get 293.7 newtons upwards. And now that we know the reactionary forces, we know where the section line needs to be drawn, we are going to then have to decide if we're going to go draw the left or the right side of the truss free body diagram. I'm choosing the right because it's the smallest section and the one with the least number of forces on it, so the calculations will be easier. I then draw the free body diagram. I indicate all external forces, which we only have the one, which is G. I then indicate the unknowns. Okay, these are the internal forces acting at DE, EJ, and JK. I'm going to assume they're in tension. And I also indicate the truss, or the joint at J. And even though it's not in this section, you can use any point to calculate a moment about. In this case, we're going to start with J because we can eliminate two unknowns, EJ and JK, and solve directly for DE. And here we get minus 290.1, which means that we assumed incorrectly, and therefore it is in compression. So it's 290.1 newtons compression. I then will take the summation of moments about E. Okay, and this is where I could have started instead of J as well. And it eliminates DE and EJ, and I solve for JK, and I get 145.0 newtons, which is in tension, and therefore I guess correctly. Then I'll use the summation of the forces in Y, and because I know the diagonal distance, I can use the ratio 7.5 divided by 9.6 as the Y component, and I solve for EJ, and I get 232.0 newtons. It's positive, I guessed or assumed correctly, and it is in tension.